All right, so I looked back at my review from last year and I realized that I didn't make a copy of the video for the last couple of pages. I might have just thought it was a little bit more straightforward than some other portions of this assessment review, but for whatever reason I didn't. So here we go. Let's give it a shot and see if we can come up with some good solutions here. So I want to know at what point this particular function has that slope of -11. So keep in mind, we know that the answer to any question regarding slope is that derivative. So I'm asking right here, when is g prime of x, that's the question, when is that equal to -11? Now I want you to notice that it doesn't say x values, it actually specifically says points, which means we're looking for full-blown coordinates. I don't just want the x, I want the x and the y that goes along with that. And notice that s at the end, which implies there could be more than one. So let's go ahead and see what we can do. So g prime of x, fairly easy little derivative. Power rule says 3 times 2/3 gives me 2x squared, plus 8x minus 5. Now again, what I want to find out is when is it possible for this particular quadratic to be equal to -11? Now that feels like kind of a random number, but I think you probably know better. It is most definitely not a random number. I'm going to move that 11 to the other side, which is going to yield a new simple equation. Adding 11 to both sides, of course, gives me 6. Now, not surprisingly, sometimes these things happen. Let's divide everything by 2, which is going to lead me down to x squared plus 4x plus 3 is 0. What do you know? Yet another example of a factorable quadratic. So it appears that the two values where that derivative is equal to -11 happen to be at x equals +3 and at x equals +11. So I know the slope is -11 at the coordinate x equals 1 and at the coordinate where x equals 3. But I do have to go back to the original problem and find out what happens if I plug in 1 and what happens if I plug in 3. So going back to the original problem, if I plugged in 1, I get 2/3. If I plug in 1, I get 4. If I plug in 1, I get -5. And if I plug in 1, I get 1. And so interestingly enough, on this problem, I actually see that if I do that, this 4, 1, 5, all that stuff cancels out. And so the coordinate is 1, 2/3. That wasn't too bad. Now, the last one that I would have would be at 3 itself. Now, of course, if I plugged in 3, 3 cubed is 27. 27 divided by 3 is 9. 9 times 2 is 18. Okay, there's a little bit of math there, but again, 27 divided by 3 is 9. Times 2 is 18. If I take 3, 9 times 4 is 36. So we're up to 54. We're going to subtract 15, and then we're going to add 1. And cumulatively, if you put all that stuff together, you get the number 40. So again, not terribly difficult, but please notice it doesn't just ask for the x value, it asks for the coordinate where that happens. Now, the next one is we have this little quadratic, and I want to know the equation of the tangent line at x equals 2. Now, as soon as you hear that chunk tangent lines have to intersect and they have to have exactly the same slope. So if they have to intersect, the first thing I need to know is I need to know what point that is. So what is f of 2? So if I plug in 2 and go through the mathematics, hopefully that's not particularly difficult mathematics. When I put that all together, I think I ended up getting -1.5. So the coordinate where these two things are going to cross is there. So remember, we have two different clarifications here. One of them is that they have to intersect. Got it. And then they have to have that same slope. So let's see, what is the slope at x equals 2? So if we consider y prime, which would be 2 times 1/2 x to the first minus 4, x to the 0. Again, I'm just kind of saying power rule in a more formal way. I got that. So of course, if I wanted to say what is the slope at the number 2, I would just have 2 minus 4, which is -2. So it appears that that equation of that tangent line would have a slope of -2 going through that point. So let's go ahead and very quickly write our point slope formula. And again, My take is I prefer point slope, but I've mentioned that my son is taking calc at Butte right now. His professor will not let him leave a final answer in point slope ever. Everything has to be converted to slope intercept, which kind of surprised me. So now let's go ahead and find the equation of the tangent line to the curve that passes through 2, -2. Now this is a little bit more of a robust question, because this point right here, what I'm telling you, is not on the curve. This makes it so much harder. So again, way harder. So the first thing that we have to do is we have to say, well, these lines have to have the same slope. Okay, now let's see what happens. I'm going to have some line that has the same slope. So let's start with the fact that it has a derivative, y prime. We already wrote that up here. Y prime was x minus 4. Now, again, I'm not going to redo that derivative. We already have that. So I'm going to come up with some equation that goes through this coordinate right here. And again, this is a little unorthodox, but I'm going to say that the slope of that line is x minus 4, whatever the heck that is, because this is the slope of the curve, but I don't know exactly what x value I want to have that happen. Now, again, it's hard to call that a line because it doesn't look like a line, but we're going to find out the right x value from the intersection, and then we'll modify this piece right here to come up with the slope. Now, if I do a little bit of math, I end up with x squared minus 6x plus 8. And so grand total, I end up with y is x squared minus 6x plus 6 as being an equivalent statement to my quasi-line statement right here. But I need this thing right here, this x squared minus 6x plus 6 to intersect, again, this fake line, this equivalent to a line story, to intersect this guy right here. Now, I don't think anybody's going to be too surprised the fact that I'm not a big, huge fan of all these fractions that are sitting through there. So we could either multiply by 2 and then move things around, or however we want to do that. But here's what I would do. I'm going to go ahead and multiply everything by 2, because I'd rather not deal with even the fraction as simple as 1/2 or 4.5 over here. I'd rather make it a little bit easier. And so moving things around a little bit at a time, I'll fix that in just a second. That should be a plus 3 equals 0. Of course, this value, 12 and 8, would actually make 4. That was kind of silly. Looking like there. So it factors really nicely to x minus 3 and x minus 1, making the values of intersection x equals 1 and x equals 3. Now, again, this seems like we're just doing all this work, but we're really poised and ready to do it, because if I'm wanting to find the equation of the line, which I have right here, what I'm going to do is I'm going to replace that slope value with the value of x take away 4. But since x is 1, 1 take away 4 is -3. And then, of course, the other one right here was we plugged in 3. 3 minus 4 is -1. Now, again, I don't really think that is a totally obvious thing. So I do think that it would be wise for us to go ahead and see what happens if we open up Desmos real quick. So let me go ahead and stop share this one, and let's reshare this with Desmos. And let's see what happens if we take a look at our problem. So I had y is 1/2 x squared minus 4x plus 4.5. That nice little curve. I have this coordinate at 2, -2, which I mentioned was not on the line, although I didn't really prove that to you. I just kind of told you it wasn't, but you can see that it didn't work. You could have plugged in 2 earlier. We, in fact, did. When we plugged in 2, we got -1.5, not 2. So it was off by a little bit. And so my first line that I came up with, again, y plus 2 equals, and x minus 2, that's again making that line go through there. And then I decided that I had 2 different values that I wanted to do. The first was a slope of -3. and the other one was a slope of -1, setting those things up. And you could see, in fact, that this purple line perfectly is tangential to the curve right here. And this other one is tangential to the curve up there. And of course, if we wanted to, instead of plugging in the number 1 and 3 into the thing over here, we could have found by plugging in x equals 1 and x equals 3 into the other curve, and we could have come up with it. So you'll notice the point of tangency happens right here at x equals 3. I'm trying to see if it'll do it. It won't. F of x. So let's check this out. F of, let's see, parentheses 3, comma, F of 3. Because we said, hey, that should have happened at 3, and it did. The other place that it happened was, it looks like when we solved that problem before, we found out that that point of intersection was 1, then, of course, F of 1. So, you know, we actually not only found out what the slope of those lines, we actually already know precisely where it's going to hit that curve if we could just take the time to find out what F of 3 is. So it would be 3 comma -3 and 1 comma 1. And those would be those points of intersection to finish that up. Okay, so hopefully this is not getting too long, but I wanted to go ahead and pack this in to get one last question into this video before we exit, because I'm going to go ahead and make problem number 12 its own video because it goes on for like a solid page. So there's a lot going on right there. So hopefully this question is a fairly straightforward one. We're looking for this story. Now I'm going to hit stop, share, and reshare because I don't want to redo this video and make sure I'm giving you the right stuff. But what we have is this ball that is thrown vertically. So this is a little hard for people to do, is to take a ball, literally throw it directly straight up in the air is what we're trying to do. And it's thrown with an initial velocity of 120 meters per second. You'll notice that's sitting right there. So I tried to give you a little bit of background about how we build these problems because they have a play from physics. This -4.9 t squared, that -4.9 has to do with the gravitational force in meters per second. So that's gravity is -9.8 meters per second squared, and so that's going to be half of that value. And then, of course, our final little nugget that was sitting right here is that we launched it from initial height of 6 meters. And that's sitting right there. Now, this particular problem is phrased a little bit backwards from how I personally like to do it. So my position as a function of time, gravity is my leading coefficient because it is the strongest force in this problem. The initial throw may have seemed pretty forceful, but it's no longer, it's not going to match up to gravity. It doesn't even matter. Rocket ships can't match up to gravity. Gravity always wins. And you go like this. So if we say, what is that maximum height? That's going to be where S prime of t is equal to 0, because when it reaches that peak height, its velocity will be 0. So we're going to call this -9.8, doing a quick power rule, plus 120. And I want to know, when is -9.8 t plus 120, 0. We'll just do a little bit of math on that, and we get 120 divided by 9.8 if you move things around ever so slightly. And if you did, of course, just a little bit of arithmetic, what you would find out is that happened at t equals 12.245 seconds. Now, that's a great answer. It's pretty good, but that's not the answer that I wanted. It says, what is the maximum height of the ball? So what I need to do is I need to go back to this original function, s, which again, I can 100% plug into my calculator. This s of 12.245, I probably should have had this plugged in already. So I got -4.9 t squared. Let's get over here, -4.9 t squared. I have to use x, right? Plus 120x plus 6. That's my nice little function. I'm going to say I had 120 divided by 9.8. That's not a pretty number. I'm going to store that as a, and I'm going to do vars y bars. I'm going to say, what happens, calculator, if I plug in that value A, and I've got a max height of 740.694. Now, again, if I had just written down the decimal that I said 12.245, you'll notice that it's very, very close. In fact, close enough that I would have gotten away with it. I like to store things in my calculator because then I have all of the decimal places just in case for some reason it's a little bit more sensitive. Now, what is the velocity of the ball when it's 400 meters above the ground? Now, this is a backwards question because my height is this guy right here. And I want to know when that height is 400. Now, will it reach 400? Well, we know it will. In fact, it will reach it once on the way up and once on the way down. And you'll notice that I tried to draw it here like this because it was 6 meters off the ground when it started. So it's going to reach it once, maximum of 740 here, and then come back down. So again, not totally sure what that's going to be, but I do know that that symmetry value is 12.245 seconds. That's where it's going to hit that peak. So whatever this distance in time-wise to there and there are going to be the same. And we'll see that in a second. So mathematically, the first thing I would do is I would subtract that 400 from both sides. And of course, if we subtract 400 from both sides, we get negative 394 equals 0. Now, here's the thing. I don't really want to solve that problem. That's just kind of irritating. So what I'm going to do is I'm going to use my quadratic formula program that I have on my calculator. And I don't have it on the one that I grabbed, so that's all right. I'm going to go program quad. Now again, if you don't have this thing, you can still do the quadratic formula on your own. It's not that hard. So we're going to go to program quad, and I'm going to plug in the number A being negative 4.9. We're going to do B equals 120 and C equals negative 394. And it says the two times are going to happen are at T equals 3.906 and at T equals 20.583. So it doesn't actually stop there because I know now when it happened, but I don't know the velocity of it. So what I need to do is I need to take my velocity function, which I had up here, and I need to take these two values, and it just happens to be that I know how my calculator stores it. But I know the velocity at 3.906, and I need the velocity at 20.583. And you should know that those two values should be the same. And I know that my calculator stores that as letter E and letter F. So I'm going to multiply this by alpha E plus 120. And on the way up, it had a velocity of 81.717 meters per second. And of course, then on the way down, if I change this to letter F, because again, that's how that program stores it, I got negative 81.717 meters per second, because they have the same speed, but velocity has a sign that is attached to it, implying that it was going up, and then of course, coming right back down. So hopefully that was helpful to you guys, and we will look at number 12 in a little bit. Bye-bye.